Review.
Nitrox, a valuable tool, not a magic potion, by Eric Douglas. Like many things, when enriched air or nitrox was first introduced to the recreational diving community, it was met with a healthy dose of skepticism. Concerns about its viability, its use, and divers' safety while breathing it created myths and misconceptions about voodoo gas that are actually still heard today. Despite the supernatural nickname, Nitrox has increasingly gained acceptance since its adoption by recreational divers, and it has proved not to be a magical potion, but a valuable tool for those who know how to use it. So who invented it? Many think of nitrox and other mixed gases as relatively new, since they've been used in the recreational diving community for only the past 20 or so years. But nitrox has actually been around and been in use for several decades. Both the United States Navy and commercial diving companies have employed it since the 1950s. In the late 1970s, Morgan Wells, who was then director of the National Oceanic and Atmospheric Administration, proposed procedures for diving with oxygen-enriched air and creating a breathing gas mixture known as NOAA Nitrox 1 or NN32. And this was named for the percentage of oxygen in the mix. The gas mix was developed based on two criteria: a maximum operating depth of 130 feet or 40 meters, and a maximum oxygen partial pressure of 1.6 atmospheres absolute. For years, the NOAA guidelines were the standard when it came to enriched air. In 1985, Dick Rutkowski, retired NOAA Diving Program Training Director, developed the first nitrox training program for recreational divers. How is nitrox made? Well, simply stated, nitrox is made either by combining or separating gas. This may sound contradictory, but it's really a matter of method. The two most common methods for manufacturing nitrox are either partial pressure blending or the membrane method. Partial pressure blending adds small, controlled quantities of pure oxygen to compressed air to achieve the desired mix. This is much like adding small quantities of very hot water into a stream of cold water to achieve lukewarm water. It takes some good control, but if done properly, it can be very effective. The membrane or gas separation method employs a semi-permeable membrane to separate nitrogen from air, thereby creating a breathing mix with elevated oxygen content. Both systems achieve the same results, which is a breathing gas with elevated oxygen, in other words, higher than 21%. It's not for deeper depths, however. Although this isn't heard as often today, when nitrox was first introduced to the diving public, it had a reputation as a deep diving gas. Ironically, the exact opposite is true. Because of the elevated oxygen levels, there are maximum operating depths. Exceeding those depths run the risk of oxygen seizures. Dalton's law states that the total pressure of a gas is equal to the sum of the pressures of its constituent or component gases. Maximum operating depth limits predict the maximum operating depths are predicated on maximum partial pressures. In other words, the pressure exerted by specific constituent gases, in this case, oxygen. While the percentage of the component within the gas mixture doesn't change during a dive, the pressure exerted on it does change as depth changes. Recreational scuba diving generally is recommended to a maximum partial pressure of 1.4 atmospheres, which is roughly about 50 meters. But when the composition of the breathing gas is changed, adjusted maximum operating depths are needed. Based on the 1.4 atmosphere limit, the nitrox mix with 32% oxygen can only be used up to 40 meters, and the 36% nitrox mixture only up to 30 meters. So why use it? Given the role nitrogen plays in certain concerns of diving, which include nitrogen narcosis and decompression sickness, It's quite easy to see why reducing one's exposure might seem appealing. By reducing the amount of nitrogen in the breathing gas and replacing it with a gas that the body metabolizes anyway, nitrox would seem to reduce the risk of decompression sickness and can even extend a diver's bottom time. But it's important to realize that you can't do both at the same time. The decreased risk of decompression sickness comes from a fairly simple concept. By reducing the amount of nitrogen in the gas mixture, the diver absorbs less nitrogen into tissues. So, compared to the risk the diver would have had breathing air, decompression sickness risk is lower when using nitrox at the same depth, but it's not eliminated altogether. So to take advantage of increased safety, divers can plan the dive as though they were diving on air and then perform the dive using nitrox, as long as they don't exceed the maximum operating depth limits of the actual gas mix. Increased bottom time comes from the concept of equivalent air depth. This means that dive tables or computers calculate the no decompression limits based on the partial pressure of nitrogen in the breathing gas. When the percentage of nitrogen is reduced, this provides the equivalent of breathing air at a shallower depth. So it is as though the diver were diving to a shallower depth than they actually are, simply because the gas composition they're breathing has less nitrogen in it. So when calculating dive times using a dive table or computer, a diver can calculate as though the dive were shallower, and as a result, it extends their bottom time. Conclusions on nitrox. Today, nitrox mixtures are readily available, and they're prepared across a wide range of concentrations. It does have a lot to offer divers, but it isn't magic. Rather, it's a useful tool that provides specific benefits when it's used correctly. When diving according to air tables or using the air setting on a dive computer, nitrox can reduce the decompression stress on a diver. When used as equivalent air depth, the safety margin is lost, but bottom time can be extended. Nitrox is becoming more popular and more accessible to recreational divers, but it's not something to take lightly. It requires special training and proper equipment. So, before diving with it, be sure to get the necessary training and appropriate certification.